Hi, it's Enes Bilgin. I'm a graduate student at Montclair State University in Computer Science Department. So this is going to be my final project. So my goal for this project is to read road signs using mini embedded system, which is going to be Raspberry Pi. So here we are using Raspberry Pi 2 Model B. As you can see, here is a 700 MHz Broadcom chip. Also, it has 256 MB RAM. Additionally, we used camera module for Raspberry Pi, which is designed by Adafruit Systems. First, we need to make connections to our Raspberry Pi with the, I just connected keyboard, mouse, and then the network cable to accomplish the secure connection with SSH with my MacBook. And let's start up our Raspberry Pi. We are starting up our Raspberry Pi. Then it's now Raspberry Pi looking for all the modules installed, and also it's gonna check for the network connection via the Wi-Fi dongle, but eventually it will find out that it's connected via network cable, so we don't need the Wi-Fi connection at all. After we reboot our Raspberry Pi, we just need to type if config to find the IP address that we are connected to network on Montclair. So it's a 130.68.57.153. I'm coming here and I'm trying to connect via SSH, which is gonna be SSH Pi 8. We are putting that IP address 130.68.57 and 153. I'm doing this because sometimes I'm using my Raspberry Pi at home headless, which means I'm not using additional screen, keyboard or mouse. I'm using my MacBook as a development environment. So if I hit that, it's gonna prompt us, it's gonna ask us password. There you go. And after we put our Raspberry Pi password, we should be in Raspberry Pi. Also, I am using open source file transfer protocol, which is NetaTalk. And to connect this, I already pre-made the line. If we hit that, we're gonna connect the Raspberry Pi via file transfer protocol. So, password again. Now we are in the home folder of Raspberry Pi where we are having development. Also, the finals folder is the last folder I have been working on. So basically here one for all algorithm is calling the algorithms from the algorithms.py and then executing them one by one. After that, we just have to locate our finals folder to run the algorithm. So we'll check the folder directory, change directory to home, pi, and finals. In finals, as we can see, algorithms executable, one for all script, and results text, and the white PNG is which we are using as a canvas. So if you go to our folder, if you see the results text file is empty and there is nothing in there. After we start processing, optical character recognition algorithm will record results into that text file as string format. So just so the last step is just running one for all algorithm, and then if we hit the one for all, it's gonna start processing images. So here we are processing images. We have couple road signs that I made them before, like 65. They are the more common ones. This is the 55 right now. We are showing our Raspberry Pi with a little bit rotating. Let's go for 80. Let's go for 80, speed limit 80. Let's go for speed limit 25. Right now, frames per second should be around 2 to 1 because of the optical character recognition algorithm is running really low on Raspberry Pi due to limited computational power of Raspberry Pi is kind of bottleneck for this project. So if you're running on this algorithm on your computer, you will be having much more better results with the faster processing. So if you go for 60, it's a little bit closer. Basically what algorithms do is like first taking the frames and then extracting speed limit string from the frame and then sending only digits to optical character recognition. Then optical character recognition returns you only numbers and to writing into the text file. So if we show AD again, that was 65, and the last one, let's make it 55. All right, let's stop our algorithm manually with Control C, and then as you can see we got almost 70 pictures with the open source algorithm Leptonica. And let's see our text file, how it's changed. If we open, as you can see the results 65, 65, 55, 55, 80. Here should be probably 55, but it read 1 as a frame, and 25, 25 here is, it doesn't read correctly, and here is other results. There is some empty space here between the numbers. This empty space, while we are changing our speed signs manually, it doesn't read the rotated, and probably it doesn't see the speed sign while we're changing speed signs. And then to explain a little bit results text file, here is the results taken by the time, is stamped by time, and stamped by the speed sign number. It's incrementing in the algorithm for starting from 1 and to last one.